Hello everyone, good morning all of you. In this session we will discuss about the P channel depletion type MOSFET. In the last session we will discuss about the N channel depletion type MOSFET. Okay, here P channel means generally this is the channel, it is made with the P type material, and remaining body is N type material. Okay, so P channel means this representation. And you know, again the source, one element is the source connected to connected through a metal element, that is source, and it is connected to a gate, and it is connected to a drain. Okay, and remaining element is filled with the N type material. Okay, here source and this P type material has the connection, there is no insulation, and same also here drain and the drain is P type material, there is a connection. But if you observe here, between gate and the channel, depletion channel, there is no connection between, because this is insulation. These shaded lines are the insulations. Okay, so this is the P type construction of the P channel type depletion type MOSFET. So this is substrate is nothing but the body. Okay, substrate is nothing but the body. So now we will discuss the working of the P channel depletion type MOSFET. Okay, so in order to understand the working of the P channel depletion type MOSFET, we should give some bias. So this is N channel, N type material, right? Here the biasing is given to the drain and source. So here we have gate and source element is there. Generally we have the gate and source element is there, and source and drain combinedly given the biasing. This drain will be reverse biased. Drain will be reverse biased. That means drain is the P type material, P type semiconductor. It is connected to the negative terminal of the supply, and here source is positive biased. Source also a P type semiconductor, and it is connected to the positive terminal of the biasing. Positive terminal of the biasing. Okay, and we don't have the any biasing for this. So in order to understand this working of the P type depletion type MOSFET, P channel depletion type MOSFET, we should give the input biasing. What is input here? Gate and source is the input. We should give a gate and source some elements. The first point, if there is no supply, if the gate and source voltage both are short circuited, so this is circuited. The first case is if gate and source is zero elements, there is no voltage, then what happened? We have to discuss. So whenever there is no voltage between the gate and source, then automatically this drain is the positive terminals, and the holes will be, the positive ions will be supplied from the supply to the source and to this. Here we have the positive majority charge carriers are the holes, and minority charge carriers are the electrons. Okay, these positive holes will be pushing, and some of the holes will be recombined, some of the electrons will be recombined, and then the holes will be pushing into the P type. From this point, the holes will be travel from these holes will be attracted by this drain. Simply the holes will be attracted by this drain. Okay, then how it varies? This variation is like this. So if you draw the graph between both drain and source, and the drain current is like this. So this is the graph. The graph is the voltage between drain and source. We are giving the drain and source voltage. This is the output voltage, yes, and this will be collected by the current. We will write the drain current. Generally the holes flow from source to drain. The current flow is always follow the holes. So that's why the current is flow from the source to drain. Electrons flow is reverse. Electrons flow is the reverse. So that's why I will write, if VGS is 0, the current flow is like this. The current is initially increases to a point, and after that it will become the constant. Here the condition I can write, gate source voltage equals to 0. So at which the current will become saturated. Then this current is called drain source saturation current, IDSS, drain source saturation current. Why? The initially the whenever the drain to source voltage increases, then the drain current will be increases linearly. After reaching some point, the drain current will become the constant. That's why this is the IDSS current. If so, we will write the first point here. The first point here, when VGS is 0. The first point I will write here, gate to source voltage is 0. If the input voltage is 0, then we will write one point. Directly the holes will flow from source to drain. Holes will directly flow. That's why the current will flow. The flow is like this. Next, so if we are giving, if the gate to source voltage is positive, then what we have to discuss here. If we are giving gate to source voltage is the positive voltage, so this is the positive, and we should remove all the things. So here also the same concept. When gate to source is the positive, here we have some positives and some negatives are there. So whenever gate to source is positive voltage is there, here some positives will be formed, and some positive will be formed. Okay. Here what happens, when positive value increases, then we have some electrons here. Then whenever a positive value increases, then the electrons from this, here some recombined. Some electrons in the n channel will be recombined with the depletion layer. So these are recombined. Whenever these holes are recombined, when we are giving the input, the current will flow, but the current value will be decreases, because number of holes in the depletion layer, P channel will be decreases. Then the current will flow, but it will decreases. So that's why we can write the graph is like this. So the graph is, whenever gate source voltage is positive, then automatically so if it is positive, then gate source value is the positive. For example, 1 volts, the current value is decreases. If gate source value is increases, then again the current flow from the value is decreases. So when gate source value is 2 volts, so still the gate source value is increases, positive value increases, then again this value decreases. So I will write, so this value increases, gate source value is equal to 3 volts. Okay, if it is still increases, for example I am still increasing to 4 volts, then current value is become the 0. The current value is become the 0. Why it become the 0? This positive, more number of electrons is attracted, then the complete holes will be 0. Whenever the holes will be 0, then automatically there is no flow, there is no holes flow. Okay, there is no holes flow. Whenever there is no holes flow from the source to the drain, automatically the drain current will become 0. Okay, for example, if the gate source voltage is negative, I mean gate source value is negative, then what happen? Generally whenever it is negative, these holes from the n channel, minority charge carriers from the this material will be attracted, the number of holes will be increases. Whenever number of holes will be increases, the current value increases. So that's why, for example, that's why gate source value is negative, gate source value is negative, then automatically the drain current value the increases. Okay, so we will write this point. What is the second point here? We will write the second point like this: if gate source value is the positive, if gate source value is the positive and increases, initially positive and that value must be increases, then what happen? The electrons in n channel, we have n channel is there, n channel recombined with holes in p channel, holes in p channel. So simply, so this is the n channel, in the n channel we have more number of electrons, these are recombined with p channel. Why? It is become more positive. Whenever it become more positive, these electrons will be attracted. Okay, electrons in n channel recombined with holes in the p channel, so the current will be reduces, so the current will be reduces, current will be reduces simply. So gate source value is negative, automatically that value increases. Okay, next we will write the transfer characteristics simply. Next we will write the transfer characteristics. So transfer characteristics, what is the transfer characteristics? Generally the transfer characteristics is input voltage versus output current, input voltage versus output current. Okay, what is input voltage? Gate source voltage is input versus output current is the drain current. Okay, look at here once again. So this is the input voltage, between gate and source voltage we are applying, and this is the output current, drain current. This is the drain output current. Okay, so we will take like this. So we will draw a characteristics, means x-axis and y-axis type. So x-axis I will use as the gate source voltage and y-axis I will use as the drain current. Okay, here starting from this is the 0 volts and increases positive side 1 volt and 2 volts and 3 volts, 4 volts and the 5 volts. Next, initially at 0 volts drain current is maximum, the 1 volt drain current is decreases, and 2 volts again drain current is decreases, 3 volts again drain current is decreases, for a 4 volts like this. So drain current is generally follow this path. The drain current is follow this path. Okay, this path will be followed. Why this path? For gate source voltage 0 maximum, whenever 1 volts compared with 0 decreases. So these are the transfer characteristics. Okay, so the simple thing, whenever gate source input voltage is less, the more drain current will be increases. Then gate source voltage is increases, then automatically the output current, drain current will be decreases. Okay, so this is about P channel depletion type. So this is the P channel depletion type MOSFET. Okay, so simple thing, just by varying the input voltages we should consider the output current. Okay, these are the transfer characteristics. Okay, I hope all of you understand the session. Thank you. So next topic is depletion MOSFET symbols. So we discussed depletion type of MOSFETs, in that how to represent in the form of symbols. Every time drawing the MOSFET is difficult, that's why the any device is represent symbols like this. So look at here we can divide into two types. One is n channel. These two are n channel depletion type MOSFETs. These two are p channel depletion type MOSFETs. So these are the p channel. So look at here, we have the gate. First the gate is there here, and we have the source terminal and the drain terminal, and in between we have the channel is there. So this is n channel type. So this is the n and the body is the p. Always it's like a diode. P n combined together, it's like a diode. That's why the arrow mark is like this. Why there is no connection? There is no connection means here the insulation between the gate and the channel. But here source is connected to source terminal, p type material, and n type material, and drain also connected to the n type material. Okay, here substrate and the source both are separate together. Okay, here what is p channel MOSFET? P channel means this is completely p channel, and we have a substrate, this is the n. That's why always it's like a diode symbol is like this, p to n. Okay, p channel to the n channel, same. And this channel, p channel and gate has insulated each other, that's why there is a gap between this, and source terminal is connected to this p type channel, and drain terminal is connected to the p type channel, and here the substrate and source both are separate. So we should write substrate and source are separated. If the substrate and the source is combined together, the diagram is modified. Same diagram, this both will be shorted. So look at here, this substrate and this source both will be shorted, and here also, here this is a substrate and source will be both are shorted. What is that meaning of shorted? So look at this diagram, look at here, just observe here is a source element and here is a substrate element. What is the substrate? Again, substrate is nothing but the body of the element. These both are combined together. Generally these are both are combined together, so that's why the symbol is like this. So we can write the substrate and source are combined together or combine together. Okay, so generally these are very much applicable, this is also the applicable. Okay, this is the symbols of the depletion type MOSFETs. Okay, only the difference, just look at, if it is N channel, always from P to N. If it is P channel, always from P to N. This is the channel, this line is the channel, and source is to combine and drain it combine, and gate and channel both are separate together by the insulating material. Okay, so this is about the depletion MOSFET symbol. Okay, I hope all of you understand this. Thank you.